To answer these questions by looking at angle A only. So the first question I'm going to have for somebody is, what's the hypotenuse in this diagram? And I don't care what angle you're looking at, the answer is still the same. But going from angle A, what is the hypotenuse of this right triangle? 228. 27. What's the hypotenuse? AB. All right, so I'm going to go backwards. I'm working backwards on purpose. AB. Now I would like to know the opposite side. And what do I mean by the opposite side? What angle are we still looking at? So I'm looking at the side opposite angle A. All right, when I say opposite, if we're looking at A, I want the side opposite that angle. And that would be 8. BC is opposite A. And I left adjacent last on purpose. Because if we're looking at angle A and I say the side adjacent and you guys usually think next to, you could give me 2 responses, right? But I already got a name for AB. What's the name we already have for AB? Hypotenuse. So when I ask for adjacent, think of leg. Leg adjacent to A. Leg adjacent, I'm not even going to bother asking. It's the one that's left, AC. So when you hear adjacent now, that's what we're thinking of. Leg adjacent, because the hypotenuse is up the hypotenuse. All right, turn your attention now to another angle, angle B. And let's answer the same set of questions. Will I have the same answers? No. No, I won't. What is the side adjacent to angle B now? Now remember, adjacent, I'm looking for a leg. What's the leg adjacent to B now? 28.
CB.
CB. How about the side opposite B? 28 again.
AC.
AC. And guess what still stays the same? Hypotenuse still stays AB, again, no matter what angle we're looking at. Okay? I will never ask you to look at the right angle. Anybody know why? I would never ask you to do that. What if I said adjacent? What are you going to ask me? Which one? Right? So I am never going to ask you to go from the adjacent angle. I will always ask you today, tomorrow, Friday, to look at these two. What type of angles are these two, by the way, A and B? I got a right angle here. I'm looking for a vocabulary term. They're not congruent. I don't know that. Acute, good. They're both less than 90. So I will always ask you to look from the acute angles, never the right angle. All good? All right. So what are these new devices I'm going to ask you to use to find a side of a triangle if everything we've learned so far doesn't work? All right. Here we go. I'm going to show you 3 new ratios today. Ratio. First, what is a ratio? Remember, that's a number compared to another number. A number compared to another number. And they have names, these ratios, that I'm going to show you. The first name is the sine ratio. It's actually spelled S-I-N-E, but we abbreviate it S-I-N. It is not called sin. Okay, let's put that out of the way. It is called the sine ratio. I don't know why we abbreviate it. I guess to stay consistent, but we abbreviate it S-I-N. And I don't know, has anybody ever seen these bad boys? It's a Greek letter. Anybody know their Greek alphabet? Oneida? No, I think omega is the horseshoe. I think so, yeah. Anybody know this one? Theta. That's theta. All it is a variable. It means an angle measure. All right, don't be concerned with it. I could put X in there and it means the same thing, but it's called theta. You can impress your friends later. Sine ratio. How do you find the numbers in the sine ratio? You take the opposite side length and put it over the hypotenuse length. Remember what we just talked about with opposite and hypotenuse. All right, so you take the opposite side and you put it over the hypotenuse side. Sine ratio. And I'm going to throw all these at you right now, and then we'll work slower and in certain problems. COS. How do you think you say that, bad boy? Cosine. Good. You piggybacked off the top and put a co in front. Cosine. How do you find the cosine ratio? We abbreviate it COS. You take the adjacent side and put it over the hypotenuse. And then the third and final ratio. Tangent. And I abbreviate it TAN. And I find that ratio by taking the opposite side length and putting it over the adjacent side length. Now, it's rare, but there are times that I do feel bad for you in here. Okay, and this is one of them. And the ice melts off the heart. buried somewhere inside me. This is a lot to remember because I'm not going to give it to you. That's on you. And I understand that's a lot to, oh, geez. Tangent, is it adjacent, hypotenuse? Which one is it? It's tough to remember. So like Hills and Sass, I'm going to give you a device to remember all three ratios and how to find them. Anybody familiar with Pocahontas? Anybody? Pocahontas? Movie? Yes, Disney movie, Pocahontas. Anybody? She had a brother? No? Yeah, she had a brother? All right. Brother's name was Sokotoa. Shoot, I don't look like an 8. There we go. Her brother's name was Sokotoa. Conveniently, her brother's name helps us remember the ratios. How? S for the sine ratio. How do you find the sine ratio? What do you think O stands for? Opposite side over the... There you go. That's how you find sine. C for cosine. How do you find cosine? Adjacent over hypotenuse. And then finally, TOA, tangent, is opposite over adjacent. So the toughest part is spelling it. If you can spell it, you can use it correctly to find the ratios. Okay? SOHCAHTOA. We're going to be using this a ton. SOHCAHTOA helps me find the ratio and what it's equal to. Questions? How many of you just soaked that all in and did not question me one bit? She does not have a brother named SOHCAHTOA. And it just conveniently goes with this mathematical concept? No, not at all. I should have let you just run with it because people would have came in. I Googled it and she doesn't have a brother. You are correct. There is no brother for Pocahontas, but you can remember it that way. SOHCAHTOA. All right, let's use it. Let's use it right now on this right triangle that I have here. 22, 18, and 13. First question I'm going to ask you, and you're just going to have to write this below. First question, can you help me find the cosine of angle A? What is the ratio of the cosine coming from angle A? So you know what angle you're looking at. Now you just got to remember, how do I find cosine? Look back at SOHCAHTOA. How do you find the cosine ratio? You take what two sides here? 8. You take what two sides? Cosine. 18. No. Just tell me in general.
Hypotenuse and adjacent.
I do adjacent over hypotenuse. Now I look at angle A, and you tell me what the adjacent side, how long it is, and how long is the hypotenuse. 16. How long is the adjacent side to A? 18 over, what's the hypotenuse? 22. Good. One doesn't make you great. Let's keep going. Let's go tangent of B. Tangent ratio coming from angle B. The tangent ratio coming from angle B. All right, well, first of all, you got to know how to find tangent. What two sides do I need to do tangent? 21?
Opposite and adjacent.
Opposite over adjacent. TOA, OA. So now, make sure you're going from the correct angle. Angle B. 28. What's the side opposite angle B?
18.
Over adjacent side?
13.
13. Great work. Everyone's all right? One more? Sure, you got it. Let's do cosine B now. Cosine B. The cosine ratio coming from angle B. This will be our last one. It's A over H. Cosine equals adjacent over hypotenuse. All right, help me out. What's adjacent and what's the hypotenuse here? 21. What's adjacent to angle B?
13.
13. Hypotenuse?
22.
22. There it is right here. And again, I kept my promise here. I only asked you about angles A and B. I would never ask for angle C because you can't. Okay, you can't. You will always be asked given the acute angle. Any questions finding the ratio before now? How do we apply it to finding a side? All right. Oh, perfect. Just what I needed here. Our techniques we've learned so far in this unit, no good. Hills and Sass. Why isn't that a no-go here? No altitude. It's not even the diagram I need. I don't even have an altitude in there. Pythag? I don't know anything about BC, so there's not enough info to plug in the Pythag. 30, 60, 90? It's not even a 30, 60, 90, right? 45, 45, same thing. So does everyone see all the methods we just learned for quiz 1 out the window? What we can use, though, for a right triangle is sine, cosine, tangent. It has to be a right triangle. I just want to make sure I mention that. It has to be a right triangle. We can use sine, cosine, tangent. So let's do it. First step, what do you have enough information to use? Which one of the 3 ratios? So let's look at the 2 sides I've given you. We know we never go from the right angle, but we can always go from the acute angle. All right, so I'm going to go from a given acute angle B, 36. What is the 15 and what is the x? Opposite, adjacent, or hypotenuse, because that'll help me identify which one of the 3 ratios I need to use. So here we go, 25. What's the 15? Oh.
Wait, what did you say?
25.
25.
Yeah, he's absent. Oh, yeah,
Okay. 9. What's the 25? The 15?
The 15's opposite.
Okay, opposite, good. And what about the x?
It's hypotenuse.
Okay, and I don't even bother with the blank side, because that's just going to screw with your mind. Just leave those 2. So you have the opposite and the hypotenuse side. So you go back to SOHCAHTOA, and you're like, all right, I got enough information to use this ratio now. And that ratio would be 25. I should have known that already. 14. Sine ratio, right? Everyone agree? I got opposite and hypotenuse, so I have enough, and I abbreviate it SIN, the sine ratio. Now, the last couple problems we did, I put angle B right here, but I know what angle B is. What is angle B? So I put 36 here. Sine of 36 degrees is equal to, now you tell me the ratio. The sine of that angle is equal to this ratio, opposite side over hypotenuse. And that's why I put those little letters there. Is that reminds me what side's which. So what's the opposite side? 6. 15 over hypotenuse, which is? Okay. So you guys have built the equation now. Now how do I solve it? Because I need to get x by itself. Let me give you this. Even though we didn't write it like this is still over what? 1. And what did I just create from our similar triangles unit? A proportion. How do we solve it? Cross multiply. Let's do it. So the first thing I'm going to cross multiply, I'll do the means here. 15 and 1. 15, right? Now let's do the extremes. Equals sine of 36 times x. So all I did was cross multiply in that step. I got to get x by itself. I'm going to ask somebody this, and it's okay if you get it wrong, but you'll probably be right. How do I get x by itself? Look what's happening between x and the sine of 36 and think to yourself, how do you undo that? How do I get x by itself? What do you think? 28 by sine 36. Now, I know some of you are asking, what is this sine 36 business, and how do I divide by it? Sine of 36 is a number, probably a decimal, too, that your calculator already has programmed into it. All right, all these values, sine, cosine, tangent, are already in your calculator. Whoa, let's not get crazy on the calcs yet. This is 36, what type of units? 36 degrees. You don't know this because we're going to go over it in unit 10, but there's another way to measure an angle other than in degrees, and it's called radians. So your calculator needs to know, when you type sine of 36, is that 36 a radian or is it a degree? And this is how you tell your calculator. You go to your mode button. Everyone see your mode? You will see in a row 2 options, radian mode or degree mode. Get it, that bad boy, in degree mode, because we're not using any radians till later on in the year. So make sure it's in degree mode. Make sure degree is highlighted. and you press enter. And from now on, you don't have to worry about changing it. It will stay degree mode unless, you give it to a friend and they screw around with it. But let's be honest, friends in this class, right? So I don't think we have anything to worry about, right, Zach? We good? Okay. Everyone else good? Zach was right there. I wasn't saying you don't have any friends, but okay. We all good? Oh, how does he know me so well? So everyone's in degree mode. You don't have to go back there ever again now. Okay. So now to figure out what x is going to be equal to, we say x equals, now I go to my calculator, fraction template, right? 15 over, everyone see our 3 new buttons we're about to use. Sine, cosine, tangent, that's what they're there for. This moment in your math career. Sine of, what was my angle again? 36? So 36, close that up. Again, that's a number. Your calculator knows what it is already. Enter, and there we go. Good? Here's my other issue in this part of the unit, is your rounding ability. Because you're not going to see simplest radical form too much anymore. Can we round appropriately? That's my concern. What's it ask us to? Nearest what here? 10. So I'm looking at 25.5, yes. Now, yeah, I know. I'm the honors teacher. I'm a stickler about a lot, high expectations. This is one battle I will not fight with you at all. I don't care if you put units or not. I don't. All right, the Regents doesn't care, so I'm not going to, if you want to throw centimeters on there, good. And if not, it's still 25.5 and it's still correct. I'm not going to fight that with you. All right, we good here. 1 doesn't make you great, right? All right, 2. Solve to the nearest inch. Again, look at the acute angle, 48. Now, some of you guys want to go nuts and find what angle W is and go from that angle. You could, as long as you go from an acute angle. All right, I always just go with whatever's given. But you could find angle W, subtract everything from 180 and do it that way. But I like here, just given what's there. All right, what's the x and the 37? Those are what sides? 4, what side is x? Adjacent, good. And how about 37? Hypotenuse. All right, so everyone take a look at SOHCAHTOA. If I know the adjacent and the hypotenuse, what ratio can I use here to find this side? Let's hear from 8 again.
Cosine.
Cosine, abbreviated COS. I don't want to put in angle V, right? Because I know how many degrees are in angle V. So I put cosine of 48 degrees. That's a number in your calculator. Equal to adjacent over hypotenuse. So how's that ratio going to look? 18. What are we looking here?
37 over x.
What A for adjacent, right? So cosine is adjacent. What do we label as adjacent? Over hypotenuse. There you go. Still put it over 1 to solve it. Now you'll notice something different happens here than the last problem. All right, cross multiply your means, and I just get what here with the means? X. And then when I cross multiply with the extremes, I get cosine 48 times 37. Do I need to divide? Like I didn't know. X is by itself. I'm good. I'm going right to my calc now. Cosine 48, I'm going to ask you to do here, watch out and close it. Because if you don't close your parentheses, your calculator is going to take the cosine of wherever the heck that number is when I multiply. And I don't want that. You're just taking the cosine of 48. So make sure parentheses times 37, and you're ready to round. Now it's what? Nearest? Yes. Not 10th, not 100th, nearest inch. So I'm looking at 25 inches. Woo! Questions? All right, I want to do one more with you, and then I'm going to let you and your group do the rest of the notes today. And that one I want to do with you. I'm just going to keep gambling. Yep. Oh, sorry. A couple too late. A little curl. Oh, pinwheel. Sorry. 5. Number 5. This one's loaded. Loaded, this problem. First thing I want to discuss, real life common sense. Okay, hopefully I don't offend anybody here. Real life common sense. A ladder, we've all seen a ladder, correct? Leans against a building. All right, so ladder leaning against we always assume the building's totally vertical, not leaning either way. So these are all going to make right triangles, all right? Okay. Ladder, leaning against the wall. Do we know where to put that 4 feet? I hope so. That's not the part I get worried about. It's this part. It forms an angle of 71 degrees with the ground. Ground. You see that thing your feet are touching right now? That's the ground. We go outside, it's still in the same place. On the ground. Not up in the air. Ground. So where am I going to put this 71? With the ground. Wait till we do shadow problems. Whew, then it gets way out of control because you'll see. How high up the wall does the building and the ladder touch? How high up? The wall, not the ground anymore. We're on the wall now. So does everyone see what side we're looking at? And I know, like I make it sarcastic and funny, but we're going to mess those up. Ground is, darn it, it's on the ground. I don't know how else to describe it. Ground. And this problem's still loaded. Forget about the diagram. This is still a loaded problem. All right, so we'll go from 71. What's the x and what's the 4? 5. What's the x?
Opposite.
Opposite. Good, Claire. And how about the 4? Hypotenuse. Great work. So what ratio should I be using here? What ratio? 17?
Or sin, sorry. Sine.
Thank you. 0 for 2 there. So sine, good, of 71. Okay, what's the ratio then? Put the sides in the SOH. SOH, what's your ratio? 10? X over 4. Good work. Again, cross multiply, put it in a proportion. Doesn't look like that big of a deal, right? When I multiply the means, I get X, so you don't have to divide anything. And then sine of 71 times 4. Sine of 71 times 4. What class in? Yeah. Yep. This is thank you. Every day I'm like, is this algebra 1, 2? You're going to see this in a lot of these honors level problems. Not only do you have to be good math students, but you have to be able to read all the way through a problem. Because there's a huge issue right now. Round to the nearest 10th of. That's not what my answer's in. What's my answer in? Yeah, that's a problem. Okay, so we have to notice that. All right, that, whoa, inch, and the diagram's in feet. That means my answer's in feet. So yeah, you're going to have to convert it out to inches now. We got it. I love to do that in this unit. Is your diagrams in one unit, and I ask your answer to be in a different one. So how can I convert this to inches now? Multiply by 12, yes. So multiply it by 12. Now you can round. So what are we looking? Nearest what? 1/10 of an inch, so 45.4 inches. Now, some of you might be pretty stealth, and you may notice this at the very beginning of the problem. If that's the case, is it okay for me to change 4 feet into 48 inches? Yes. All right, so that either you do it at the beginning or you do it at the end, but you got to do it somewhere. All right, so please start watching out for the units changing on your diagram to the answer. Good? All right, you guys are going to go back to number 1. I'm just going to come walk around, look over your shoulder. If something's wrong, you'll know.
We got another building.
Okay? If something's wrong, you'll know.
Yeah, she gave us the building.